In this video, I am going to discuss about welding defects. Welding defects can be defined as any irregularities present in the weld method. The main reason for welding defects are incorrect welding parameters, wrong welding procedure, wrong combination of filler metal and parent metal, etc. So these are the main reason for producing a welding defect. So any irregularity that will be present in the weld metal is known as welding defects, and they are produced mainly due to incorrect welding parameters, wrong welding procedure, wrong combination of filler metal and parent metal. Various welding defects are crack, porosity, solid inclusion, lack of fusion, inadequate penetration, imperfect shape, and miscellaneous defects. So these are the various classification of welding defects. So we can discuss one by one. First one, crack. See, the main reason of crack is localized stress exceed the ultimate tensile strength of the material. The localized stress that will be produced in a welded joint exceed the ultimate tensile strength of the material, the crack will be produced. See, the stress will be developed mainly due to shrinkage during solidification of the weld metal. See, during solidification of the weld metal, shrinkage will be occurring. That shrinkage will develop a localized stress. If that stress exceeds the ultimate tensile strength of the material, the crack will be produced. So solidification shrinkage is the main reason for crack defect. Then that crack may be longitudinal crack, transverse crack, and radiating crack. There are three classifications of crack that will be occurring in a weld metal bead. See, this is the weld metal bead. That is first one, longitudinal crack produced in longitudinal direction, transverse crack that will be in transverse direction, and radiating crack. So these are the three types of crack that will be produced in a weld metal bead. See, what are the main reason for crack? The main reason is solidification shrinkage. Other reasons are poor ductility of weld metal, high sulfur and carbon content, high arc travel speed, fast cooling rate, too convex or concave weld bead, high hydrogen content, etc. So lot of reason will be there for producing a crack in a weld metal bead. The main reason is the stress produced during solidification shrinkage, and others are poor ductility of the weld metal, high sulfur and carbon content, high arc travel speed, fast cooling rate, too convex or concave weld bead, high hydrogen content. Okay. Second one is the porosity. See, porosity is due to gases entrapped in the solidifying weld metal. That's the main reason for porosity, and these gases cannot get escape, and the gas occupied space will not filled with the molten weld metal. Then there will be a vacant space will be produced, that is known as porosity. So the main reason for porosity is the gases entrapped in the solidifying weld metal. These gases are generated from the flux or coating constituent of the electrode, shielding gas during welding, or from absorbed moisture in the coating. So these are the reason where the gases will be absorbing by the mold metal. So absorbed from the moisture or shielding gas or flux or coating constituent of electrodes. See, the porosity may be easily prevented if workpiece are properly cleaned from rust, dust, oil and grease. See, before the welding process, if you are cleaning the workpiece properly, the porosity can be avoided. See, in porosity defect, there are three configurations. First one, uniformly distributed porosity. The porosity will be uniformly distributed in the weld bead. Second one is linear porosity. Linear porosity means the defect is seen in one line. and third one is clustered porosity. Clustered porosity means it will be visible as a clustered form. So these are three configuration of the defect porosity. Okay, so the main reason for the defect porosity is gases which is absorbed by the molten weld metal or entrapped by the molten weld metal. Okay, so third one is salt inclusion. See, salt inclusion may be in the form of slag or any other non-metallic material entrapped in the weld metal, as these may not be able to float on the surface of the solidifying weld metal. See, what you mean by salt inclusion means slag or any other non-metallic material which is entrapped inside the molten weld metal and which cannot be able to float on the surface of the solidifying weld metal. Okay. So the slag inclusion can be prevented if proper groove is selected. All the slag from the previously deposited weld bead is removed. Too high or too low welding current and long arc are avoided. So in this way we can avoid the slag inclusion defect in welding. So this is a slag inclusion defect. So slag inclusion defect means slag or any non-metallic constituent that is trapped inside the solidifying weld metal. That is known as slag inclusion. Next one is lack of fusion. See, this is the defect, lack of fusion. See, lack of fusion is a failure to fuse together either the base metal and weld metal. Failure to fuse together either the base metal or weld metal or subsequent bead in multi-pass welding. So what is the meaning of lack of fusion is failure to fuse base metal and weld metal. See, in this figure you can see that it will failure to fuse the base metal and weld metal, or otherwise if we are following a multi-pass welding process, failure to fuse subsequent bead. See, these are subsequent bead. If there is not proper fusion take place between the subsequent beads, that is also known as lack of fusion. See, the reason is failure to rise the temperature of base metal or previously deposited weld layer to melting point during welding. That's the main reason for lack of fusion welding defect. Failure to raise the temperature of base metal or previously deposited weld layer to melting point during welding process. Okay. Next one is incomplete penetration. See, incomplete penetration means the weld metal is not completely penetrating up to the distance we required. See, incomplete penetration means weld depth is not up to the desired level or root face have not reached. So the weld depth is not up to the desired level. That is known as incomplete penetration. The reason for incomplete penetration are if either low current or large arc length or large root face or small root gap or too narrow groove angle are used. These result in poor penetration. So what are the reason for incomplete penetration is low arc current, large arc length, large root face, small root gap, too narrow groove angle. These are the reason for producing incomplete penetration in welded joints. Next one is imperfect shape. See, imperfect shape means variation from the desired shape and size of the weld bead. So weld bead means this is the weld bead. So which have not a proper shape. That is known as imperfect shape defect. Next one is undercutting. See, a notch is formed either on one side of the weld bead or both sides in which stress tends to concentrate, and then it can result in the early failure of the joint. So what do you mean by undercutting? A notch is formed either one side of the weld bead. See, you can see that here is a notch is formed, or both sides of the weld bead. That is known as undercutting. See, due to the undercutting, there will be high stress will be concentrated here and it will leads to early failure of the joint. Main reason for undercutting are excessive welding current, long arc length and fast travel speed. So these are the main reason for undercutting defect. Excessive welding current, long arc length and fast travel speed. Eighth one is various imperfect shape. See, various imperfect shapes are produced in the weld. So here first one underfilling. This is also underfilling. This is lap joint and this is 90-degree joint, T joint. And this is overlap, excessive reinforcement, linear misalignment, excessive slack, excessive root penetration, distortion. So these are the various imperfect shape during welding process. So these are all defects actually. Underfilling is a defect, overlap is a defect, excessive reinforcement is also a defect, linear misalignment, excessive slack, excessive root penetration, distortion. See, the excessive reinforcement is formed by high current and low voltage, slow travel speed and large size electrodes are used. That is the reason for excessive reinforcement. Excessive root penetration and slack occur if excessive high current and slow travel speed are used for relatively thinner material. Distortion is caused of shrinkage occurring during large heat input during welding. Okay, so these are the reason for some various shape defects. So reinforcement, excessive reinforcement is formed due to high current, low voltage, slow travel speed. A large size electrode are used. Excessive root penetration and slag occur if excessive high current and slow travel speed are used for relatively thinner material. Distortion is caused because of shrinkage occurring due to large heat input during welding. The last one is miscellaneous defects. These are multiple arc strikes, spatter, grinding and chipping mark, tack weld defects, oxide surface in the region of weld, unremoved slag and misalignment of weld bead. So these are all miscellaneous defects in welded joints. So multiple arc strike, spatter, grinding and chipping mark, tack weld defects, oxides surface in the region of weld, unremoved slag and misalignment of weld beads. So in this video I have discussed about various welding defects. So you have to study the various welding defect and understand what is the main reason for each welding defect. Okay, thank you.